This is part 2 of section 3.3. We've been talking about long division. All right, so if I want to divide 4x squared minus 8x plus 6 by 2x minus 1. First thing we need to check is to make sure that all of our exponents are there, that we haven't skipped over any, and they're all in the right order. And here we have a second power, a first power, and a constant. They're in the correct order. Nothing was skipped over. First power, constant, everything here is good as well. So I'm going to set this up as 2x minus 1 divided into, remember to space this out a little bit more than you think you should, 4x squared minus 8x plus 6. Okay, so when we're doing this division, we concentrate on our first terms. So I have a 2x and a 4x squared. What do I need to multiply 2x by in order to get a 4x squared? Well, to change the 2 into a 4, I need to multiply it by a 2. And the x to an x squared needs to be an x. So I need to multiply that overall by a 2x. Now take this 2x and distribute it through here. That will give me 4x squared minus 2x. Now let's change our signs here because we subtract this whole polynomial away. And now the first term cancels. I have negative 8x plus 2x, which is a negative 6x. And now bring down the plus 6. And we repeat the process. I want this 2x to become a negative 6x. Well, to change the 2x into a negative 6x, I need to multiply this by a negative 3. Take the negative 3 and distribute it. Negative 3 times 2x is negative 6x. Negative 3 times negative 1 is positive 3. Now we need to subtract this, so change your signs. That's a plus, that's a minus. The first terms cancel out. And then we have 6 minus 3, which is 3. Okay, so we've done all the work now. We have a remainder this time. This did not divide evenly into this, so 2x minus 1 is not a factor of this polynomial. To check this, I could take 2x minus 3 and multiply that by 2x minus 1, and then add 3 to that, and I should get this whole polynomial right here, this trinomial. How do we write our answers? Well, our answer is 2x minus 3 plus the remainder, which is 3, over what we were dividing by, 2x minus 1. Okay, now how did we know we were done here? There were a couple of ways. First of all, if you were lining up your like terms when you did this part up here, you're out of spaces. Okay, we also have nothing left to bring down. That's another good sign. But the main sign is that the degree, which is the largest exponent of whatever you have right here, has to be smaller than the degree here. This has a degree of 1. This has a degree of 0. So as soon as that is smaller, we are done. Okay? Now what that means for us is that it is possible that our remainder still has some x values. Like if this is a degree of 4 and this is a degree of 3, then I have a remainder that still has an x in it. So you can't let that scare you too much. Okay. So let's do this with 2x to the 5th minus 8x to the 4th plus 2x cubed plus x squared divided by 2x cubed plus 1. Now the first thing we have to do is to make sure that everything is in order and all of our exponents go down. But we also have to make sure that we have every single exponent represented. And we do not have that in this case. Here we start off with a 5th power. When we go down, we have a 4, a 3, a 2, but we do not have a first power and we do not have a constant. In the denominator, we have a 3, but we do not have a second power or a first power, but we do have a constant. What we need to do is we need to put these places back in, and the way we do that is we use placeholders of zeros. So basically, instead of solving this problem, what I'm going to solve is 2x to the 5th minus 8x to the 4th plus 2x cubed plus x squared plus 0x plus 0. Numerically, I'm just adding a 0 here, so I haven't changed the value of up here at all. But I do have, basically think of these as open places. I need some place value. I need some holders. Okay? And then I'm dividing this by 2x cubed plus 0 times x squared. That's just a 0, adding 0, not really changing anything. Plus a 0x, and then plus 1. I need all of these zeros as placeholders because if I don't have them, this whole thing is going to get totally messed up. Okay, so let's go solve this long division. 2x cubed plus 0x squared plus 0x plus 1 divided into 2x to the 5th minus 8x to the 4th plus 2x cubed plus x squared plus 0x plus 0. Okay, so we concentrate on our first terms. I want to multiply the 2x cubed by something and end up with 2x to the 5th. Well, the 2's are the same. Here I have 3 x's. I need another 2. So I'm going to multiply this by an x squared to get to here. So x squared. Take the x squared and distribute it through this whole thing. You're going to keep these zeros around. It's going to feel kind of silly, but just keep it around. So this is a 2x to the 5th. Plus, it doesn't matter whether you think of it as a plus or a minus, it's a 0. 0x to the 4th, because x squared times x squared is x to the 4th, but it's a 0, so it doesn't really matter. Plus 0 times x cubed, plus x squared. Now let's change the signs of everything, and of course changing the signs on the zeros doesn't matter. Our first term should cancel out, and it does. And then I get negative 8x to the 4th plus 2x cubed. Now this also canceled out. I want to keep a 0 around over here. If a 0 happens in the middle or on the right, you want to keep it around. Now you might end up not needing it, but it might be really important, so keep it around for a while. This is a 0x squared, and I'm bringing down the rest of this, plus 0x plus 0. Now we're going to concentrate again on our first terms. I want the 2x cubed to become a negative 8x to the 4th. So to get the 2 to a negative 8, I need to multiply that by a negative 4. I have 3 x's, I need 4, so I need one more. So it's negative 4x. Now take the negative 4x and distribute it through this whole thing, keeping your zeros. Negative 4x times 2x to the 3rd is negative 8x to the 4th, as it should be. And then I have plus 0x cubed plus 0x squared minus 4x. Now I wrote pluses here. Don't let that mess you up. It could be minuses. It's 0. It doesn't really matter. Okay, so let's change all of our signs. Plus, minus, minus, plus. Now what happens here? Our first term cancels, as it should. Then I have 2x cubed plus 0x squared plus 4x plus 0. Okay, one more. I want the 2x cubed to become a 2x cubed. Well, it's already exactly what I need, so I'm just going to multiply that by a positive 1. So plus 1. Take the 1 and distribute it through here. And I get 2x cubed plus 0x squared plus 0x plus 1. Okay, change the signs on everything here. And now combine like terms. The first term goes away as it should. The second term is now on the left of this, so I don't need the 0 anymore. Okay, I have 4x minus 1. Now this is my remainder. The degree here is a 3. The degree here is a 1. So this degree is smaller than this one, so I'm done. I also have nothing left to bring down, and I've used up every space here. So my answer is x squared minus 4x plus 1, which comes from up here, plus your remainder, which is 4x minus 1, over what you were dividing by. And you don't need to use the zeros when you're writing this, so you can come back up to here. The zeros are necessary for the long division process. It's not part of your answer here. So this is over 2x cubed plus 1. To check this, I could multiply x squared minus 4x plus 1 by this, and you don't need the zeros when you're checking it. And then I would add 4x minus 1 to that, and I should get this polynomial right up here.